So hello students, welcome to the class of Electric Charges and Field previous year's question answer discussion of 2014. Now in this year we want to learn how KCT have asked the questions in 2014, what was the pattern, what are the things they wanted us to know, and how we can approach the problem to solve it in less than 30 seconds. So this is our main strategy on what we are working about. So let's unravel the video. The first question I'll be first solving in detailed manner so that you can understand, and then I'll show how to solve it in 30 seconds. Okay. So the first is what is given in the question. The basic is to read the question. Spherical conductor of radius 2 centimeter. Okay, no problem. Now this part, spherical conductor, radius is there. How much is the radius? 2 cm. Okay. So always write down the radius as in meter. So centimeter, 10 power minus 2 meter, done. That much I know. Uniformly charged with this much of charge. What is the charge given here? 3 nanocoulomb. Nano means what, student? You should know. 10 power minus 9 coulomb charge. Done. What is the electric field at a distance of 3 centimeter? At a distance of 3 centimeter from the center. At this point, they want to find the electric field. So here, what KCT wants us to know? What is the electric field formula? And what is the electric field formula? K Q by distance square. K Q by R square or D square. So this is our D. Okay. So this basically K value. Now, if you know the K value is nothing but 9 into 10 power. How much? You all know 9 into 10 power 9, correct? So K is equal to 9 into 10 power 9. Q is equal to 3 into 10 power minus 9 divided by D square. D is what? Our radius. So that is equal to at a distance of 3 centimeter. So 3 into 10 power minus 2. That's it done. Now a lot of people will ask, sir, what is the use of this 2 centimeter? There was no use. The charge was outside. If it was inside, there would have been a different story. Nothing more than that. Okay. So which formula to use for a spherical thing? That is important. Okay. Now for the reduced syllabus kids, those who will be watching. So this is not there, but you should know it. Okay. So anyway or the other, you're doing for your PU and you're doing for what you say J and all that. So that will be helpful. So what you can see directly, this and this you can cut. 9 into 27, and this one directly you can see 27 by 3. So you'll get 3 here. And this power is cut, and power what you'll get? 10 power 4. That's it. Now let's say if I want to solve this question, okay, by 30 seconds, how I'm gonna do? So in that case, let's say if I want to solve this question by 30 seconds, what I should know and how I should do is, let's start the stopwatch. So first, this 3 is same. So I'll be worrying about the power values, correct? So let's see. So spherical conductor, they are asking me the electric field. Electric field formula is what? Directly I should know the electric field, KQ by D square. K value directly, 9 into 10 power 9. Okay, I'm worried about the formula, the powers only, that's it. And what about the distance? 3 centimeters. So 3 into, what about the charge? 3 nanocoulomb, 3 into 10 power minus 9. And what about the distance? 3 into 10 power minus 4. So forget about what you say the values, just cut this and find out the power. Oh, it should be 10 power 4. Any value with 10 power 4, that should be the answer. That's it. Clear? So you should solve it like this. Nothing was there, directly electric field formula, put the value, get the answer. So here you can save. You could have solved less than 5 seconds. I showed like this formula, that formula. Directly you could have written. Okay. Directly electric field 9 into 10 power 9. Okay. Charge 3 into 10 power minus 9 and divided by the distance 3 into 10 power minus 2 whole square. So this and this gone, this went up, so 10 power 4, and this cut. Okay. So this and this cut. So we got here answer 3. So 3 into 10 power 4. That's it. Correct. So what was so difficult about it? Learning the electric field formula? No. Seeing it and applying it on the fast moment in the exam is important. For that, you need to practice more and more. The more and more you practice, the more better it will be. Okay. So that's it. So let's see the next question. In the next question, a very simple, what is the nature of Gaussian surface involved in the electrostatics law? So we know what is Gauss law. You should know what is Gauss law. What do you know? Surface integral E dot ds is equal to what? Charge enclosed by epsilon naught. So what they are asking here is, they're asking is, for the Gaussian surface, this surface, is it electric, is it magnetic, is it electric, is it vector, is it scalar? What is it? So if you see ds vector, there is a vector sign above it. It's a vector quantity, that's it. Clear? So directly we know area vector is what? A vector quantity, and what it does always shows upward direction, the upward normal, okay, or the outward normal. That's it. For any kind of vector, area vector is outward normal, always coming out. If I'm like this, if I'm showing it like this, always coming out. That's it. Nothing was there in this question, correct? Coming to the third question, a very good question, okay, for this part. Let's see. So what is there in this question? First, we have to read two equal and opposite charges of mass m1 and m2. You accelerated in the electric field some distance. Very simple. So one field is there, and you have two equal and opposite charge. One mass m1, one mass m2. Charges, let's say q1, equal and opposite charge. One is minus q. So if I apply a force on a charge, what is the force formula? Electric field is E. Okay. So F is equal to QE, and that is also is equal to what? Mass into acceleration, M1 into A1. Now for the other, F is equal to minus QE, and that is equal to M2 into A2. But the force magnitude formula, magnitude value, magnitude of this F1 force and F2 will be same, yes or no? Why? Because only the negative sign changes the direction, nothing more than that. So what will happen? Directly I can write M1 A2, A1 is equal to M2 A2, correct? So I can write A1 by A2 is equal to what? M2 by M1, and that is equal to 1 by 0.5, and that is equal to 1 by half. So that is equal to 2, correct? What was so difficult about it? Learning force formula, nothing. See, force formula, whenever we know a charge is there, electric field is there, force is equal to what? Q into E. Force is equal to what? Charge into electric field. And the other formula, the moment it has motion, it has acceleration, force formula is what? Mass into acceleration. That's it. So if you remember these two formulas, this question is very, very, very simple and very easy. Correct. So now let's understand how do we solve it in less than 30 seconds. Now for the 30 seconds, first read the question very fast. Equal and opposite charge, mass m1 and m2 accelerating uniform electric field through same distance. Directly I know charge is there kept in a uniform electric field. What will happen? So force will be same. So F1 and F2 will be same, and that is equal to QE. It will be equal to minus QE magnitude wise, and that should be equal to M1 A1 is equal to M2 A2 directly. So what I need? A1 by A2 is equal to M2 by M1, and that is equal to 2. That's it, done. So it should be less than 30 seconds, nothing more than that. Okay, clear? That's it. Coming to the next question, a very simple question they have given. Now here, what KCT wants us to know? A body of charge 1 nanocoulomb. So first they want to know what is the charge? Q is equal to 1 nanocoulomb, so 1 into 10 power minus 9. Correct? Now if you see, one is the odd value and rest is all same. Correct? And then one has got a good power. We'll see. Very simple without solving also. How do we solve it? Okay, we'll see that also. So first charge is equal to given how many electrons are present. So we know what KCT wants us to know. What KCT wants us to know is that you should know this formula that Q is equal to NE. Q is equal to what? NE. Q is equal to what? NE. So Q is equal to charge, and charge is what? 1 into 10 power minus 9 coulomb. And that is equal to what? Number of electrons, we don't know that. And charge on each electron, 1.6 into 10 power minus 19. So if we just solve the power also, n is equal to 10 power minus 9 by 1.6 into 10 power minus 19. So if you solve this, you'll get somewhere around 10 power 10. And if I solve this part, I'll get somewhere this formula, 10 power 9. So I don't need to solve the whole thing exactly, correct? So you should understand. So in exam, what you should do? And if I want to solve it in less than 30 seconds, what I'm going to do? Directly a formula should come, Q is equal to NE. Directly put the value 10 power minus 9 is equal to N, I don't know, into 1.6 into 10 power minus 19. So N is equal to what? 10 power 10 by 1.6. So that is near to the fourth value done question. So this is the way you have to approach the problem. Not thinking here, there, and all that. Okay. And I have given you exact formula, what is needed, what was required by you in the concept video. So refer to that concept video. Make it like what do you say? The follow it religiously. What I say, you mean to say is each and every line of the concept book should be like thoroughly revised in your brain. You can easily put it up in a question so that you can easily apply in any of the questions and solve the questions very fast. Okay. So that's all for the 2014 section. All the questions were like either F is equal to QE or Q is equal to NE or F is equal to MA. Nothing more than that, or electric field formula K is equal to E is equal to KQ by D square. That's it. So nothing else is there. Okay. If you understand the whole simple, what is it, 2014, 4 questions, 4 marks you could have got just by knowing that the force is equal to what? Charge into electric field, or by knowing force is equal to mass into acceleration, or just by knowing Q is equal to any quantization formula. So nothing tough comes from KCT. Don't get scared. You have ample amount of time to prepare right now also. Do join the course, do work hard, and for the content coming up very fast. So don't worry, everything will be finished by March. Okay, that's a promise.